Hi guys, today we're starting Unit 3, and this is Learning Target 1, adding, subtracting, and scalar multiplication of matrices. Just a little history before we start. Between 300 BC and 280, Chinese test gives first known example of the use of matrix methods to solve simultaneously equations. Matrix was introduced in 1850 by James Joseph Sylvester. Side note on Sylvester, he had a brief career at the University of Virginia, which came to an abrupt end after he was upset for a student reading a newspaper in class that he struck the student with a sword stick and fled the country believing he had killed the student. Matrices were used in World War II to encode and decode messages, and currently the application of matrices are in most scientific field, every branch of physics, computer graphics, and much more. For Google search, they are used to determine the page rank. For application, you would know are games such as Sudoku and the 2048 tile game. So dimensions of matrices are described as rows. So rows going side to side, and by columns going up and down, okay? So if we're talking about this first one here, this would be column 1. Sorry. Here we go. Column 1, this would be column 2, row 1, and row 2. Okay. Same thing for this. When it shows you rows by columns, so you would label this as a 2 by 2. For this second one here, we have 2 rows by 3 columns. So it would be a 2 by 3. And this last one would be 3 rows and 2 columns. So this would be a 3 by 2. To add and subtract matrices, they must be the dimensions, must be the same dimensions. So same rows by columns. Okay, so example 1, we have given C equals this 2 by 3 matrices, and D, this also is a 2 by 3. What are the following? So C plus D, what you're going to do is add all the ones that are in the same place. So where this 3 is, that would be our first one, plus 1 in our D column. Then your first row, second column, 2 plus 4. First row, third column, 4 plus 3. And then second row, first column, -1 plus -2. Second row, second column, 4 plus 2. Second row, third column, 0 plus 4. So what you're doing is just adding the ones in the same spot. Okay, so our answer here, we have to go through and add them together. 3 plus 1 gives us 4. 2 plus 4 gives us 6. 4 plus 3 gives us 7. -1 plus -2 gives us -3. 4 plus 2 gives us 6. And 0 plus 4 gives us 4. So C plus D equals this 2 by 3 column. Or 2 by 3 matrices, sorry. So pretty simple in adding. Same kind of thing for example 2 when we're subtracting C minus D. So everything that's in the same spot. So we're taking 3 minus 1 now. And then 2 minus 4. And then 4 minus 3. Make sure you're keeping them in the same order. So -1 now, minus a -2. Okay, and then 4 minus 2, and 0 minus 4. So our answer, 3 minus 1 gives us 2. 2 minus 4 gives us negative 2. 4 minus 3 gives us 1. Negative 1 minus a negative 2, so this becomes a positive here. So negative 1 plus 2 gives us a positive 1. 4 minus 2 gives us 2, and 0 minus 4 will give us a negative 4. So our answer here is this 2 by 3 matrices, okay? All right, moving on to scalar multiplication. Scalar multiplication is finding the product of a real number and a matrix. Multiply each entry by the scalar. Okay, so it says in example 3, if A is this 2 by 3 column and B equals this 2 by 3 column, what is 4A plus 3B? So what you would have to do here first is take 4 and multiply everything in your A by 4. So actually, let me write it like this. So we're going to be finding out what 4A equals. So let's go ahead and rewrite our matrix of A. So 2, 8, negative 3, negative 1, 5, and 2. Now I need to multiply each of these by 4, so I'm just going to put parentheses around them and put a 4 in front. All right, so if I did this now, I'm going to get a new matrix of 4 times 2 to give me 8, 4 times 8 to give me 32, negative 3 times 4 to give me negative 12, 4 times negative 1 to give me negative 4, 4 times 5 to give me 20, and 4 times 2 to give me 8. Okay, that would be my answer for 4A. Now we need to see what 3B equals. So 3B is going to, we're doing the same kind of thing. I'm going to go ahead and plug everything in. And I'm multiplying everything here by 3. Okay, so our new matrix, we're going to start with 3 times negative 1 to give us negative 3. 3 times 0, which is 0. 3 times 5 to give us 15. 3 times 0, 0. 3 times 3 is 9. And 3 times negative 2 to give us negative 6. Now that we have 4A and 3B, now we just need to add them together. Okay, so I'm going to do 8 plus a negative 3 to give me 5. 32 plus 0 gives me 32. Negative 12 plus 15 gives me 3. Negative 4 plus 0 gives me negative 4. 20 plus 9 gives me 29. 8 plus a negative 6 is going to give me a positive 2. Okay, so this would be your final matrix answer. All right. So we can also solve equations with matrices. So example 4, what values of x and y make the equation true? So what you're going to do is have to take what you have here, so where your x is, take your 3x plus 1 and set it equal to what it equals, so that would equal the same thing as 16. Okay, so to solve this, I need to start by subtracting 1 from both sides. Cancels out there. Bring my 3x down. 16 minus 1 gives me 15. And then I would have to divide by 3 on both sides. 3 divided by 3 is 1. I get x. 15 divided by 3 is 5. So you could also make sure that this works and do 3 times 5 plus 1. Well, 3 times 5 is 15 plus 1 equals 16. So that works out for that one. Now we're going to do 2y minus 1. And that would equal negative 5. Now we're going to solve for y. Start by adding 1 to both sides. Cancels out on this side. I'm left with 2y. Negative 5 plus 1 is going to give me a negative 4. I'm going to divide by 2 on each side. So y would equal negative 4 divided by 2 to give me a negative 2. Go back and check this one as well just to make sure. I'll have 2y minus 1, plugging in negative 2. 2 times negative 2 gives me negative 4 minus 1, and it has to equal negative 5. And that does work. So negative 4 minus 1 equals negative 5. That one is correct as well. Okay, so you would have to say x equals 5 and y equals negative 2. Okay, and that is all for adding, subtracting, and scalar matrices right now. Have a great day, guys.